Now, listen, for us right here, please, everybody, I said I wanted really to do the word problems, all right, because I feel like those are the most important things. So what I need everybody to do is I need everybody to look at number 32, please. All right. And I only had a couple people who got it right last time, so my explanations have not been all that great. And I think this is one of the most important lessons right here, dealing with money, percentages, finance. All right, that's important to everybody. Everyday activity, percentages everywhere. All right, so you need to know how to use them. So, what was the fee? What was the fee? Palmer, tell me.
58.5.
$58.50. I'm not saying that's correct. I'm just saying that's an answer. What did you get?
15.
Wow, same thing. Wow. That one? Yeah, wow. Good. Tell me. Just 5. All right, I'm happy with that. I'm happy with that. Anybody else? I'm not saying that's correct, guys. Again, remember, I don't care about the right or wrong answers. I care you tried to do it. And some of you read it like, I don't know. All right. I don't like that. Come on, try. All right. Now, let's first start with this. 18%. I would like you to recognize that as we're trying to find a part of the what? Whole. We're trying to find a part of the whole. All right, we're trying to specifically find what part? 18%. That's what we're trying to find. We're trying to find 18%. Is 325 a part or is 325 a total? It's a total. All right. So I told you, if you want to separate a total, what you're going to end up doing is taking the percentage, all right, and multiplying it by the total, and that will separate it into the parts. So everybody take 325 and multiply it by 18%. Now, how do you multiply something by 18%? Change it to a decimal. Thank you. And when I change it to a decimal, it really is 325 times what? Yes, 0.18. So help me out with that. Is that right? 58.50? Yeah. All right. So I'm happy with that. Really, that's much better. All right. All right. Much better. Now, again, guys, I'm telling you, this is just crucial to understanding numbers. All right. And if you don't know, you got to tell me what.
I don't get, because I thought you divided it after you got 58.50 because I got that, but then I divided by 325.
Well, if you did watch this, everybody take this on your calculator. Take and hopefully you'll understand what I'm saying now. If I do, everybody look up on the board, 58.50 divided by 325 without doing it on a calculator. What is 58.50 divided by 325? And I'm making the calculation right now in my head, doing the math. What is it? 18%. I didn't have to do the math. That's what we just calculated. Do you understand that now, right? So if I do 58.50 divided by 325, if that's not 0.18, then we don't understand. You with me? I'm splitting the 325 into 18%.
Oh, okay.
That's what you're doing. All right. So now with that, please stay with me. What's this answer? Yes, I just want the answer for now. I'm trying to see how good we are. 53.32. What are you thinking? 51.40. What did you think? Good. Molly.
28.
Just 28? Good. What'd you get?
27.65.
27.65.
27.70.
Good. What did you get?
53.200.
53 point what? All right. Anybody else want to just, I mean, those are kind of close. Nobody else? Now, look, we've all gone to the store and we've all seen where you walk in and it says 10% off. And you see another sign that says 25% off everything else. All right. So you're getting two discounts. Most people think if they take 25% off and 10% off, they're getting a total of what? 35%. Is that true? No. If you go into a store and something says 50% off, and then they said, because they're going out of business, we're going to take another 50% off. Does that mean you get it for free? No, it means you get 50% off, and then they take 50% of the other price. All right. That's what they do. All right. You don't ever add percentages. All right. So in this case, all right, she finds a bird bath that is on sale 10% off. So how do I find 10%?
Okay. But you moved the decimal over.
Right. So I'm going to multiply 79 times what?
Point one.
Yes, times 0.1. All right. And what is that?
Which is 7.1.
Yeah, $7.90. That's my discount. You're discounting it 10%. So what's the price with just the 10% off, please?
Oh,
Do it right now. Tell me what it is. 79 minus $7.90.
$71.
Yes, thank you. Now you look up and you say, wow, this is my lucky day. I get another what? 25% off. So what do I do with the 71.10 and the 25%?
You divide. Or no, sorry. Wait.
You what?
Sorry.
We're trying to find 25%. We're trying to make 25% off. How do I find 25% off of $71.10?
You
It's nothing different.
what?
You multiply 71.10 times what? 25% off times, yes, you multiply 71.10 times 0.25. So now do that on your calculator and tell me what that discount is. $17 point, so we'll make it 78, right? So I got 1778 is that discount. Does everybody have that number? So what's my final price after all that? What do I do with those two numbers?
You add them together and then you subtract.
No. This is why this has already been discounted once. It's already been discounted to $7.90. So what do I do with this sale price and this discount? You want to pay more, huh? Right? If you go to the store and you take 25% off, you don't go, wow, you're so generous. Let's just add that to the bill. Is that a discount if they add something to the bill? So obviously we would do what with that? Subtract, right? So now everybody take 71.10 minus 1778. Tell me what that is, please. Your little finger should be on the calculator, punching the buttons. All right, I'm doing it with you. What is it? Somebody said the sale price is equal to 53 what? Somewhere around $53.32. Did anybody else get that? Wow, somebody did. Wow. Good work, whoever said 53.32. Mr. Greep, tell me.
There's 79 on 0.1.
Okay, look at this. And look, I'm just trying to make sure you understand numbers, right? You ready? 0.10, 0.100, 0.1000000. What's the difference?
Zeros.
Just the zeros. Do the zeros mean anything?
No.
So it's the same. All right. Anybody else on that problem? All right, you learned a lot today. If you just learned that, you now know how to go into a store, and when you see two discounts, you can figure out how much you actually have to pay. All right, yes.
How you would know how to send it.
Well, I don't,
I figured out how to send it in the super.
what did you do?
I did 79.1 and then equals 7.9, and then I subtracted that from the total.
Yep.
And then I did what he did up there, but I still got it wrong.
No, that's not possible. Take 7110 on your calculator, 71.10, and multiply that by 0.25.
$17.77.
That's your discount. Now you have to subtract that from what? From how much? No, these were just the answers. So let me just get rid of that because that's confusing some of you. From what?
71.
Yes, of course, because that's the sale price so far, right? But you got another discount coming. You with me? All right.
Because what if I did 79.25?
That would still be the same answer, believe it or not. Yeah. That's the nice thing about multiplication, right? It's commutative. It doesn't matter what order you do it. All right. All right. That was a good question, actually. It doesn't matter what order, you get the same answer. All right. Now, okay, come on now. What is this? That's okay. Come on, I'm happy. Good. 13% is nice. What did you get? 48%. What did you get? 12.5%. Come on, Molly, don't make a big deal out of it. Go. 8%. Go. 1.08. 4.8. 8%. Come on. What? 92%. Good. 92.59%. 8%.
I got 4.8.
Okay, guys. Tell me. 48. Okay, listen now, guys, that's kind of embarrassing. All right. I didn't do a very good job, and I'm sorry. Let's figure this out. First of all, on this 600 and this 648, does that look like a lot of tax or a little tax? I mean, so how much tax did we pay? Let's start with that. $48 in tax. Does everybody agree with me? So we paid 48. So in the grand scheme of things, is that 90% of that? So none of the 90s are really working, correct? What's 10% of 600? Has to be less than what? Has to be less than what? It has to be less than 10%. Is everybody with me on that? Come on now. All right. So now I want to tell you, part to whole. How much is our tax? 48. Now, some of people last class misunderstood what I was saying when I said part to whole. What was the whole price of the computer? Nope. 600. 600. You with me? The government has to take their greedy hands and get into your pocket and take your $48 because you bought a computer. Does everybody agree with that? Right? So they took 48, right? So the tax is always the tax divided by the total cost of the purchase. And what did you purchase?
A computer.
Which was cost?
600.
Right. So it's just 48 divided by 600. And somebody do that for me.
That's 0.08, which is also known as
0.08, which is the same as 8%. Thank you. That was a nice job. All right. So again, I got my work cut out for me now on percentages. I got my work cut out for me. All right. So we still have lots of work, and today's work will help you with that. So I'm going to put my video on pause here for a quick second, and I'm going to collect the. All right. So percent of change is something extremely important. You need to be able to calculate and to find percentages. All right. And I already told you a percentage is part to what? Part to whole. That's the way you want to think about it. Part divided by the whole. Now that's always going to give you a what? Decimal, right? And then you multiply by 100 to get to the what? To get to the percentage. That's all there is to it. Part to whole, part to whole. All right. So this is the way I figured things out. All right. I want to find the percent of change. I want to find the percent of change. So if I'm going to find the percent of change, I need the what? The change. All right. So the percent of change is equal to the change divided by the original amount. All right, that's a little formula. The change divided by the original amount. Now, of course, that's going to give me a what? Decimal, that's correct. And so what am I going to do to the decimal? Multiply it by 100. That is correct. And if you multiply that by 100, all right, that will give you the percentage. All right. Again, it's really crazy easy. All right. I'm not going to even spend a lot more time with you. All right. So let's see if you understand what I was talking about. And someone in the last class asked me a question, and that just shows you're not listening. All right. So I'm on number 1. I went from 12 to 18. So what's the change? 6. All right. Now, is it an increase or a decrease?
increase.
Now, if you don't know if it's an increase or decreasing, I'm not sure how I can help you. Right? I don't expect you to write increase or decrease because why? It's obvious. All right. So this is definitely a what? An increase. How much did it increase by? 6. What was the original? 12. So 6 out of 12 we know is just what? 50%. 6 divided by 12 is sometimes 2 in your math world, but in my math world, it's 0.5.
Okay.
And 0.5 is the same as 50%. 0.5 is the same as 50%. All right. Anybody have any doubts about that? What?
So if you have 6 over 12, wait, never mind.
Right. Okay. So everybody take a look at number 3. I went from 48.50 to 38.80. All right. Let's say your stock price went from 48.50 to 38.80. What percent did it go down? All right. What do I have to do?
First, I subtract.
Yes. And tell me what that is. And then I divided by.
Divided by 48.50.
Yes, ma'am.
20%.
Exactly. All right. Anybody else get exactly 20%? But sometimes there's some decimals on these problems. They're not going to work out exactly.
Oh, wait, it was 0.2.
Yeah, 0.2 is, that's the point. 0.2 is 20%. What? Were you having trouble finding the change? How do I find the change from 12 to 18? What do you think?
Well, I know it's an increase. I don't.
No, but I'm asking you, how do I find 6 with 12 and 18?
Because there's 6. It's 6 increase.
So, but how do I calculate 6? Let's say I didn't know that was 6. How would I calculate 6? There you go. That's it. Difference means, guess what? Subtraction. Yeah, difference means subtraction. That's an easy way to remember it. All right, change. All right, you always subtract and divide by the original. All right. So number 5, we went from 10 to 3. Tell me.
First you have to, put the difference,
Which is
7,
divided by
10.
10, which equals. You're not using a calculator for 7 divided by 10. Look at y'all, little fingers on the buttons going. 7 divided by 10 is obviously what? What? Which is
70.
70%. 7/10 is 70%. All right, here we go. No one wants to hear your explanation of how you got 3 for that. All right, number 7. All right, tell me. Shh.
50 minus 18.
And what is that?
4.
4.4. That's right. I'm listening.
18. And you get 0.24 and then like a bunch of decimals.
So now I don't like to say it's 24%, right? Because I don't want people to think it worked out evenly. Do I really care about the rounding though? No. So if we're going to round, we're going to say it's like 24 point what?
24.5.
Yeah, about 24.5%. That lets the person know. That lets the person know it wasn't exact. All right, 24.5%. How's that?
Will it be completely wrong?
Well, no, I don't mark things completely wrong because you're off by a decimal. All right. But I want you to hear what I'm saying. I don't like to put exact numbers if it's not what? Exact. All right. So if I went from 28 stray cats to 5 stray cats, my population decreased by what percentage? So what do I have to do to solve this? Why 24 over 28, please? Are we having trouble with 28 minus 5 today?
You should not be talking.
Go. Tell me, Molly.
23
Good job.
over 28.
Yes, 23 over 28. All right.
And that goes 82.1%.
Yeah, about 82.1%. Now, does everybody understand why I like to put the 82.1? Because I don't want the person to think that it was exact. All right, 82.1%. I'm happy with that. Now, when you're finding the percent of error, right? Let's say my actual speed was 38, but I thought I was going 35. Which one is more important? The one that I thought or the actual?
Actually.
Of course, the actual. So the percent of error is the same idea. It's the difference between your estimate and your actual divided by the important number. And the important number isn't your estimate, it's your what? So in this case, Reed, what's my fraction? Tell me my answer. No, we forgot the change. 3 divided by 38. I like it. Now, as we go down, they're trying to trick you by writing them backwards. All right. So you got to be real careful. The actual is the one that's important. The difference between the actual and the estimate, all right, is what we mean by the difference. So tell me what 3 divided by 38 was about.
I said something.
7.9%. Is everybody agreeing with 7.9%?
No.
What's 3 divided by 38?
0.078. So wouldn't that just be 7%?
Well, if he's going to round it,
Yeah. Wait, no.
well, no, I don't look. You guys, I don't really care. That's why it's we are wasting time if he said 7.9 and you're telling me it's 7.8. I don't really care. What did you want it to be?
7%. Well, like, because
Is it exactly 7%?
no,
No, then I don't like to put 7%. You see what I'm saying, right? So when I round it to one decimal place, if you think it's 7.8 and he said 7.9, we're not having a discussion. I don't really care. What?
could you still put 7.5?
Is that what 3 divided by 38 is? Is after the 7 a 5? No, you see what I'm saying? Right, we didn't do that. All right, come on, 12. Let's make sure we can get this right. What do I do?
Okay, so, it's
5
over, uh, over 50,
5 over 50.
and then you divide that,
Mhm.
and you got this 1.
Yes,
10%.
yes.
Nailed it.
Tell me,
Why would you divide 50 and 45?
what have I been saying to you? What is the most important thing? What you estimate it to be or what the actual is? Yeah, it's always divided by the actual. And I even told you they're going to switch it up. So you have to pay attention. You see what I'm saying? They just wrote it backwards just to throw you off. Okay. Miss Wood, you're up. 13. What do I have to do for this?
I did 1.
1. That's it. And everybody, of course, should know that's just. And yes, because we understand 0.3 repeating is 1/3. 33 and 1/3%. Does anybody have any issues with that? Nobody?
I got a fish in bubble dancing.
We don't care.
All right, Mr. Greep,
I do 1 over 2.
because 2 is the projected, not the actual,
Oh,
right? Come on now. I'm gonna let you do 14, Mr. Greep.
okay. 30
30.
over 230.
Yay, now you're listening.
And then we got 13 in one decimal, so 13.
Point what?
5.
Is everybody else agreeing with that? 13.5% roughly? Is that good?
Yeah.
What?
It says 13, 13 like around 0 on here.
13.
And then it has a bunch of. Like, like 13, 0, 4, 3, 4.
13, so it's 0.1304 what?
13.043472.
Okay, is that what you got, Mr. Green? Okay, so here we moved the decimal 2 places. So if I were turning this problem in, I would say it's 13.04%.
Oh, yeah.
You with me? You can't just leave out the 0. Sorry, what?
So you just put the actual cost on the bottom?
Every time, actual. Actual is the important part.
I didn't.
Yes,
Why did you put the function?
because I know it's not exact. Equal mean, that's right, that's right. Okay, help me out with 15 before we turn you loose. You ready? Tell me what to do. How much? You're awesome, buddy. Is that exact? So it's going to equal what percentage? That's exactly correct. Now, does everybody understand how if I put 12 down, that means it worked out what? Exactly 12%. All right. I don't want, if it doesn't work out exact, I want it rounded. All right. And I'm not really too concerned about rounding. All right. Because you made it out of 2nd grade. All right. Some of you. All right. Now, I want everybody to turn the page, please. Shh. So I want you to finish 21 to 40. 21 to 40, guys. I want everybody to try 21 to 40. That's it. All right. And you should be able to finish by the end of class because all you're doing is subtracting and dividing with the calculator. All right. Classwork right now. You're getting busy right now. Finish it up immediately. No one's asking you anything. Shh.